Okay, this is optimization 1, basic. Right, and here's the problem that I'm going to solve. Okay, we have a box with a square base. It has no top and a fixed total surface area of 1,200 square centimeters. I want to find the largest possible volume of the box. Okay, this is very similar to problem 8, except that in problem 8, they don't tell you the fixed surface area. They don't give you a number for that, so you just have an A there. Okay? Okay, so basically what's going on here, let me draw the box. Something like that. Let's see. Something like that. Okay, we got X, X, and H. Okay, so what I'm saying is it's a square base, so the length and the width of the base we can call X, and the height we'll call H. Okay, so first off, the volume of the box is length times width times height, so X times H, which is X squared H. Now here's the problem. The problem is that we want a function. So I'll call it v of x. We want a function in terms of x, but here we have a function in terms of x squared and h. So we have to eliminate the h. Now to do that, we'll have to use the extra information. Okay, so the extra information is that the surface area is 1,200. Okay, so that's the extra information. All right, so we need to find a formula for the surface area. Okay, so let's see, surface area. So the surface area is all the amount of space on the outside of the box. Like, basically think of it as if you're going to wrap the box, but not wrap the top with wrapping paper, then how much paper would you need? Okay, something like that. All right, so it's the area of the base, plus the area of each of the sides. So the area of the sides. Okay, now there's only one base, but there's 4 sides. Since we have a square base, each of the sides is going to have exactly the same area. So it's 4 times the area of one side. Okay, so let me write that out horizontally here, plus 4 times area of a side. Okay, the area of the base is length times width, so that's x times x, plus 4 times the area of the side is x times h. Okay, we were told the surface area is 1,200. So here we have 1,200 is x squared plus 4xh. All right, now, so remember we have v of x is equal to x squared h. So let me just write that here, x squared h. But we want to eliminate the h. So we'll solve this equation for h, and then we'll plug that into there. Okay, so we got x squared times something. Okay, so we'll solve for h. So 1,200 minus x squared is 4xh. Dividing by both sides by 4x. We get that h is equal to 1,200 minus x squared over 4x. Okay, so the volume in terms of x is x squared h, and h is that, so we have x squared times 1200 minus x squared over 4x. Okay, so now we have a formula for the volume, and we're going to try and find maximums and minimums and determine which is the maximum. Once we have the maximum, we'll know that that's the maximum. That's the x that gives you a maximum volume. Okay, so v of x is this thing. Now we want to set up, now we could take, so remember, to find the critical points, the potential maxes or mins, we need to take the derivative and set it to 0. Okay, so we're going to take the derivative of this function here. Now, taking the derivative of this guy, we could use the product rule, but it would be a mess, right? You have a product rule with a quotient, all kinds of stuff there. So we might as well, let's push the x squared into the top, okay? So you can think of this as x over 1, multiplying these guys together, we get 1200 x squared minus x to the 4th over 4x. Okay, so there's just another way of saying the volume there. Okay, much easier to take the derivative now. Okay, so v prime of x, and we'll use the quotient rule, 4x squared on the bottom. Okay, so the derivative of the top, let's see, that's going to be, bring down the 2, you got 2 times 1200x minus 4x cubed times the bottom, minus the derivative of the bottom, which is 4, times 1200 x squared minus x to the 4th. Right. So simplifying the top now, we'll distribute this 4x through that stuff. Let's see, that's going to give you 4 times 2 is 8. I'm going to give an 8 times 1200 x squared minus 16x to the 4th. So 4 times that, I just multiplied the 4 times 2 to give me an 8. I left the 1200 there. X times x is x squared. Oh, I'm not going to need that anymore. Okay, so minus 4 times 1200 x squared plus 4, so negative times a negative is plus 4x to the 4th, all over, let's see, that'll be 16x squared there on the bottom. Okay, so now v prime of x, we can combine like terms. Let's see, v prime of x, so I'm going to bring this stuff up here. Okay, I got 16x squared. So now you can see why I left that 8 times 1200 and the 4 times 1200, because they're like terms anyway. So you can think of it as the like terms are this piece there, and now 8 minus 4 is 4, so we have 4 times 1200 x squared minus 16 plus 4 is a negative 12 x to the 4th. Right, it'll be conducive later to have this top factored out, so I might as well just do it now. All right, so notice that I can take a 12 out of there. This is a 12 times 100, so I can pull a 12x squared out. And let's see, what am I left with? A 4 times 100, that's a 400, minus, so 400 times 12, 4 times 100 times 12, okay. There, the x squared is taken care of. 12x squared, I need an x squared there. Okay, all over 16x squared. So that's my v prime. V prime is equal to that. I set it equal to 0. and solve for x. Okay. All right, so we have a fraction equal to 0. That means the top has to be 0 because it's not fractions aren't defined with a 0 denominator, so we must have 0 equals 12x squared times 400 minus x squared. Two things multiply to give you 0. One of them has to be, so we know 12x squared equals 0, or 400 minus x squared equals 0. This one right here will give you x equals 0, or 400 equals x squared. Taking the square root of both sides, let's even move this up here. Plus or minus square root of 400 is x. All right. Little trick here, 400 is 4 times 100, right? So that's 2 times 10 is 20. So plus or minus 20 is x. Okay, so now we found our critical points. Oh, that's right, very good job. You know that the critical points occur at when v prime is equal to 0 or v prime is undefined. So v prime would be undefined when 16x squared was equal to 0. 16x squared equals 0 is the same as x equals 0. We already found that one there. So in this case, it's repeated. All right, so our critical points are 0, plus or minus 20. Write that down. We got our CPs, our critical points are 0, negative 20, and positive. Okay, you got that? All right. Now we can throw 2 of these out, right? Because this is the width of this is the length and width of the base of the box, right? It doesn't make sense for x equals 0 to be the length and width of the base. X equals negative 20, that makes no sense. You're not going to have a length of you're not going to have much of a box if the length and width of the base is 0. It doesn't even make sense to have the length be negative 20, so we throw those out. So the only thing we need is the 20, right? So at this point we can see that x equals 20 is probably the right answer. Okay, it's probably the right answer, but we don't know for sure. We may have found a minimum, and we want to find a maximum. So if we want to find a maximum, but we actually find the minimum, then we've done the worst possible thing. Okay, so we need to make sure that 20 is in fact a maximum. So we'll make a little sign chart. All right, so critical point there. Pick something to the left, pick something to the right. You might as well pick 1, because 1 is really easy to test in v prime. All right, pick 21 over there. All right, remember that v prime, we found this to be 12x squared 400 minus x squared over 16x squared. All right. So v prime of 1, if you put a 1 in there for each of the x's, you can see that this will be positive. 400 minus 1 will be a positive number. 16 times 1 is positive. The v prime of 1 is positive. We have increasing. Okay, v prime of 21, see 21 squared is positive. 21 squared would be positive, so it really matters what happens here. If this is negative, then it's negative. If that's positive, then it's positive. Let's see, 400 minus 21 squared, that's going to be a negative number. So we know that v prime of 21 is negative, we have decreasing. Okay, so we're increasing to our critical point of 20, or decreasing after our critical point of 20. So that says that's a maximum. So 20 is a maximum. All right, so so in fact, we do have the right answer. But if we found that it was a minimum, then what would we do? We would say there'd be no solution. Okay, so how do we say our answers? All right, so x equals 20 centimeters gives the maximum volume. The maximum volume is V of 20. Plug that back into V, 20 there. Cubic centimeter.